Hello everybody. Alright, so we're going to talk about another topic related to variables, and that is type compatibility. So you might be wondering, what the heck is type compatibility? So I'll give you a nice definition. We're trying to figure out if two variables are type compatible. And the way we can determine that is if the value of variable A can be assigned to variable B when A and B have compatible types. Okay, and there's two flavors of type compatibility. There's name compatibility, and that means that variables have the same type name and their structure, and that means when variables have the same structure. Alright, I'm going to do examples of both of these. Alright, so let's look at a name compatibility example. A name compatible example. Alright, so here I have a count, which is of type integer, and I have index, which is of type integer, and then I say count equals index, and index equals count. So life is good. By the way, this is an example in Ada. Alright, so since count and index both have the same type name, they're considered to be type name compatible. Alright. Alright, so now I'm going to come up with create a new type. You can do this in Ada. You can just create types on the fly. So type index type equals, is, the syntax right here, is 1.100, and then I'm going to say count is of type integer, and index is of type index type. So clearly count and index have different types. So if I attempted to do this in Ada, count equals index, Ada would not let me do that. And if I were to try to say index is equal to count, Ada wouldn't let me do that either, so this is Ada. Ooh. There we go. Ada. Okay. So, now, this is interesting. So I'm continuing the name compatibility. So let's say we're continuing in Ada, and I have a variable A, which is of type integer, and B, which is of type float, and I say this, I say B is equal to A. So the question I have for you, again, this is in Ada. The question I have for you is this okay or is this not okay? So take a moment to think about it. All right. So if you answered it's okay, I can see how you would say that, because in Java, this is perfectly fine. If you have something that's an integer and something that's of type double, you can set the double equal to the value of the integer through a process that's called upcasting. Now, upcasting is actually a sort of, I guess you could say, I would say it's a Java-specific description of something called type coercion. And what type coercion does is, so actually what I'm going to do is, let's see how this works. Oh, that's cool that I can do that. Okay. So I'm going to write the same code in Java over here on the right. So int A, double B, and then somewhere down here I could say B equals A. So this is okay in Java because of type coercion, which is what we say in Java. We call this upcasting, right? We upcast the integer A to a double, and because an integer occupies 4 bytes, a double occupies 8 bytes, there's no problem taking that integer and converting it into a double. All right, so we're in effect coercing. It's like, come on, A, you really don't want to be an integer. You want to be a double. And then we assign B to that double. In Ada, because Ada uses pure name compatibility, typing, this is not okay. So this is okay, and over here in Ada, it's not okay. So that's something that's interesting about the language. You may not know anything about Ada, but it was a language that was developed by the Department of Defense and was pretty much required for a lot of coding for over a decade. If you wanted to write systems for the Defense Department, it had to be done in Ada. And it turned out that Ada lost favor with developers and with the Defense Department because it was a huge monstrosity of a language that was just so rich and had so many special cases and circumstances around it. And it was built by a giant committee of people that would sit in a room coming up with what the rules were going to be for the language, that it became really challenging to develop systems in the language, complex systems in the language. But one of the ideas behind Ada was, the code for some of the systems that were being developed in Ada were systems that would, run nuclear weapon systems. And what you wanted to make sure when you were building software that would run those kinds of systems is you wanted to make sure that they were as safe as possible. So this is an example of that kind of safety. Should you be taking an integer and assigning it into a float? The answer is no, unless you do something explicit to make sure that it's okay. So we don't automatically upcast or coerce the integer into float. We're going to have to do something else to convert that integer into a float. Okay. All right. Let's take a look at structure compatibility. So consider this. I have this, and this is made up using Ada. So you actually would not be able to do this in Ada, but I want to illustrate the point since I've been giving you examples in Ada. If I said A was an array from 0 to 10 of integer, and I said B was an array from 1 to 11 of integer, then a language which is structurally, that supports structure compatibility, would say that it would be okay to say that A is equal to B, or B is equal to A. All right, so this is Ada, but it's actually made up. You would not actually be able to do this, and so we're going to say this is an Ada-like language, because you wouldn't actually be able to do this. All right, now I have some questions about Java. So is Java name compatible? Is Java name compatible? And if it is, can you give me a piece of code to demonstrate that? So think about that for a second. Are variables in Java name compatible? So the answer to this is yeah, it is. Let me give you an example. If I say int a comma b, I can say a little later on in the code, I can say a equals b or b equals a. Is Java structure compatible? Structure compatible. Can you prove or disprove that? So the thing is, like, if you say yes, you got to prove it, and if you say no, you got to prove it. All right. So is Java structurally compatible? So the answer to this is no, it's not. And I'll give you an example. Here's an int a, and let's say char. Ugh. Try that again. Char c equals new char 4. Now, A references 4 bytes because an integer is 4 bytes, and C is a reference. Well, so A is a 4-byte integer, and C is a reference to a 4-byte character. So if I attempt to say A equals C, that's going to be an error. And C equals A, that's also going to be an error. Okay. All right. Now, you might say, but wait, I've got an example that might be yes. And I say, all right, talk to me about it. Can you? And so you say, well, what about this? Yes, question mark. If I say int a, all right, and I say float b, isn't it okay for me to say b is equal to a? And doesn't that show type compatibility? Because a is 4 bytes, and b is 4 bytes, 4-byte float. And if I can say b equals a, isn't this showing type compatibility? And the answer is no. This is the ability to assign a value from A into B is thanks to type coercion, which we just talked about. So it's not really type compatible. What we're seeing is an example of type coercion. So type coercion allows this, not type compatibility. All right, well, that takes care of our discussion of type compatibility. And stay tuned for the next little video lecture where we're going to talk about scope.